Hey everyone, and welcome. Today, we are pulling back the curtain on a field that's totally changing the game, from the shows we binge watch to the way we shop. We're going to demystify data science.
Okay, let's just start with this number right here, 2.5 quintillion. That's a 25 with, get this, 17 zeros after it. That is the insane amount of data that we, as a species, generate every single day. And the crazy part? That number is just getting bigger.
I mean, it's a mind-boggling amount of information, right? So it really begs the question, with this constant tsunami of data coming at us, what in the world are we supposed to do with it all? How do we make sense of any of it?
And look, this data isn't being generated in some sterile, far-off science lab. Nope, it's coming from us, from you. It's our smart cars talking to our phones. It's our TVs, our refrigerators, even our coffee machines. It's every single social media post, every chat, every single search you type into Google or show you binge on Netflix. It's basically the digital exhaust of our daily life.
And here's where we hit a wall. You see, the tools we used to use, things like a basic spreadsheet, they just can't handle this, not even close. They were built for a much smaller, quieter world. This is a data deluge, and it meant we needed a completely new way of thinking.
And that's where the story really gets interesting. Because out of this massive challenge, this problem of just too much information, a really powerful new field was born, data science.
So what is it really? When you boil it all down, data science is basically the process of finding the hidden gems inside all that data. It's part art, part science, but the goal is always to take that raw, messy, chaotic information and turn it into something useful, something that helps us solve really tough problems or just make smarter business decisions.
You know, this leads to what I think is the absolute best way to think about a data scientist. They're not just crunching numbers. No way. They are digital detectives. Seriously, whenever they get a challenging question, they put on their detective hat. They're sifting through clues in the data, looking for those hidden patterns, trying to crack the case.
Now, every good detective has their toolkit, right? A data scientist is no different. So let's crack open that toolkit and see what's inside. What are the core components they use to go from data to discovery?
Okay, so you've got two main players here. On one side, you have statistics. Think of this as the foundation, the bedrock of the whole operation. It gives us all the tools we need to measure things, analyze them, and visualize the data. Then, on the other side, you've got machine learning. And if statistics is the foundation, machine learning, well, that's the engine. This is the part that uses all that data to spot patterns. And here's the magic trick. It actually teaches computers to learn and adapt all by themselves when they see new information.
So how does that engine actually get started? Well, first up, you have data exploration. This is where you're really playing detective, just digging into the data, looking for any interesting clues. Next comes model building. Here, you're using algorithms, which are really just sets of instructions for the computer and feeding it a bunch of training data to build a predictive model. And finally, you got to test it, right? That's model evaluation. You throw new data at it to see how efficient and accurate it is before you let it loose in the real world.
Okay, so that's the theory. But theory is one thing. Let's see what happens when these digital detectives actually get on the case. We're going to look at a couple of real-world examples from companies you definitely know.
All right, our first case file sounds like it's straight out of a mystery novel, Walmart's Hurricane Secrets.
So you've got Walmart, right? The biggest retailer in the world. They started using this technique called data mining, basically sifting through mountains of sales data looking for gold. And they found something weird, something no human would have ever just guessed. They discovered that right before a hurricane was about to hit, sales of strawberry Pop-Tarts would just explode. We're talking 7 times the normal amount. The data saw the pattern when we couldn't. And that one little insight, it let them stock their shelves before the storm, making sure they had what people wanted.
Next up, a company that probably knows what you want to watch tonight better than you do. Yep, we're talking about Netflix.
You see, Netflix isn't just taking a wild guess when it suggests a new show. It is constantly analyzing the viewing patterns of its millions of users to figure out what actually gets us hooked. And this isn't just about powering that recommendation list you see on your home screen. It goes so much deeper. They use these insights to make huge multi-million-dollar business decisions on what new shows and movies to actually create. Why? Because the data has basically already told them there's an audience waiting for it.
So when you look at these examples, from Pop-Tarts to producing blockbuster shows, you start to see what this is all about. It's not just about numbers, it's about a fundamental shift in how we make decisions.
And this really brings us to the most crucial point of this whole thing. All that data we talked about at the beginning, that 2.5 quintillion bytes every single day, on its own, it's just noise. It's static. Data science is the detective work that cuts through all that static and finds the clear signal. It's what turns all that noise into valuable knowledge, and that knowledge into action.
Which kind of leaves us with one last question to chew on. Think about it. The connection between a hurricane and a breakfast pastry was completely invisible, a totally hidden pattern that nobody saw until data science brought it to light. So it really makes you wonder, if data can predict that, what other invisible connections are just sitting there, waiting to be found? What's it going to predict next?